have discussed in lecture that about the dipole antenna. Now with the help of simulation we can see actually how the radiation pattern looks like, and so we are discussing some different type of antenna that is called like the Yagi udha antenna, in which we have these are the specification. It is also considered as a antenna arrays. So for that in Yagi antenna we have one driven element, one direct, maybe one or two director based upon the application we can take, and we have a reflector. So these are the specifications given for this Yagi udha antenna. For we have given the length of the antenna, length of the driven element, length of the reflector, length of the director one. These are the specifications we have given, and based on this we are designing this Yagi antenna. So already we have discussed in theory lecture what is the how this pattern looks like, but actually we will simulate and we will see how it looks like. Okay, so now we are going for the simulation. So you can see here from there the STD we have mentioned whatever the parameter we have mentioned, we have given all the parameters here, and based on that whatever the distance between director, whatever the distance between driven element, whatever the distance between dipole to director, dipole to reflector, everything we have mentioned in this parameter list. Based on that we can see after all this value we can see the we can further check the components, what are the components we have taken. So in the components we have this director 1, director 2, director 3, reflector. Okay, and after simulating the result we can see. So now simulation begins. After the simulation we can see the actual radiation pattern what we have discussed in theory lecture. So now it is executing. So we have designed this dipole antenna for 0.9 gigahertz. For this we have given this specification. And we are simulating this using CST Studio software. This is for the education purpose, and we will see the various parameter like VSWR, this S parameter, reference impedance, balance, power, energy, matrix, everything we can see just after simulating those values. So we are doing this simulation based learning just to. Okay, so now you can see from here we can see the S parameter is there. We can see the S parameter value. So this is the S parameter at 0.9 gigahertz. You can see here. Now further we can see the VSWR also. This is the VSWR. Now we can see the Y matrix also. We can see the energy, power, whatever we want we can see. So this is the actual simulation we are doing, whatever we have learned in our theory classes. We can also see the 2D and 3D patterns. Here we have so as we have discussed in class, our radiation parameter is calculated for the far field region. So for far field region you can see this is the whatever the equation we have studied in lecture. Based on that this is a E theta. This is the 3D dimension of 3D representation of this radiation pattern, in which everything is mentioned: radiation efficiency in dB, total efficiency, directivity, everything we can simulate here and we can learn based on that. Okay, thank you.